Okay, we are going to now look at motion maps with acceleration. So before we only showed velocity by showing the direction and how fast an object was moving. Right now we're going to show acceleration, so we're going to show motion maps that have a change in velocity. What that means is we're going to have an additional row of arrows that show the acceleration. So we'll do a couple of examples just with the motion maps, because I think we all feel pretty good about getting from motion maps to graphs. So this is just going to look at the 4 different cases that we had previously looked at, increasing and decreasing speeds in both positives and negative directions, and we'll look at what those motion maps for each of those would look like. So starting with the first case, increasing speed in the positive direction. Here's our motion map. And we're going to make this qualitative. Let's say we've got our velocity vectors, so we're starting anywhere. Let's start at 0. And we're moving in the positive direction. Increasing speed. So what that means is that my arrows are going to be getting longer. Before they were the same size, now they're going to be getting longer. So let's say I went 1 segment, and then I went 2 segments, and then I went 3 segments. And then I could keep going, but for now let's just look at these 0, 1, 2, 3 seconds. My velocity, and it might actually be easier to put numbers with this. So let's start at 0 meters. We'll say this is 1, 2, 3, 4, 5, 6, 7. The object began moving at, this is 1 meter per second, and then it moved 2 meters per second, and then it moved 3 meters per second. So each second, the velocity was increasing by 1 meter per second, which means that my acceleration would be increasing the velocity by 1. So I want to show a second row now with acceleration vectors. And you do want to label which one's velocity and which one's acceleration. And what the acceleration is showing, 2 things. First, the direction of the acceleration. Second, how much acceleration. So since all of the velocities are increasing by 1 meter per second every second, my acceleration vectors should show exactly how long that increase is. You want these to line up. So you want the dots to line up for the acceleration. So I have 3 seconds. My dots should all line up with the 1, 2, 3 seconds. And if I were to keep going, I would have one over here. I ran out of room, so I didn't keep going. So 0, 1, 2, all line up. Again, if I kept going, I would have that. And you know what? Let's just alleviate any confusion and get rid of these dots. So now, again, my acceleration is showing how much the velocity increased every second. It increased by 1 meter per second every second. So all of my acceleration arrows are going to be the same length as each other. The reason being, it's a constant acceleration, so the acceleration is not changing. I show the constant acceleration by having these equal length arrows. The velocity is no longer constant, so the arrows are no longer equal lengths. It's increasing speed in the positive direction. Velocity is positive, pointing to the right. Acceleration is positive, pointing to the right. Another way of looking at this is saying that this plus this equals this. So 1 meter per second plus an additional meter per second equals 2 meters per second. 2 plus 1 equals 3. If I keep going, 3 plus 1 would have equaled 4. So this is how you represent acceleration in a motion map. I'm going to do 3 more for our 3 more cases so that you can see what those motion maps look like. And do know that we can have combinations. So obviously something might not be increasing or decreasing the whole time. You can have more than one thing happening in a problem. So let's look at the next 3 cases. Second, we're going to do decreasing speed in the positive direction. Here is my axis. Let's say 0 meters, 1, 2, 3, 4, 5, 6, 7. Again, this doesn't have to be with numbers, but for some of you it is easier to see numbers. This could be completely qualitative as well. So if we are decreasing speed in the positive direction, that means that I am starting out quickly and then I'm getting slower. So for my velocity vectors, let's say I start going 3 meters in 1 second, and then I go 2 meters in 1 second, and then I go 1 meter in 1 second. So writing what these velocities are, this is 3 meters per second, 2 meters per second, 1 meter per second. My acceleration is going to be negative. Again, if you're decreasing speed, velocity and acceleration are in different directions. So my acceleration is going to be negative and taking away from the velocity. So for my acceleration, I need to show that the arrows are pointing to the left. And these dots are going to line up a little bit differently. There's not a dot above that one. So they all need to be 1 meter long. And you're showing that 3 minus 1 equals 2. 2 minus 1 equals 1. And then eventually, if it was staying at this, 1 minus 1 equals 0. So if it was continuing at this acceleration, then after these 0, 1, 2 seconds, the third second it would be stopped. So acceleration and velocity are going in different directions, but again, the acceleration arrows are all the same length as each other. The velocity arrows in this case are getting smaller. Our third case will be increasing speed in the negative direction. Making my motion map. Our velocity is all going to be going to the left. And let's just do this one qualitatively to show that this can be qualitative. So we're moving to the left and we're getting faster. So let's start 1, 2, 3. So this is starting at 1 segment per second over here, 2 segments per second, 3 segments per second, all in the negative direction, so they're all going left. If something is increasing in speed, velocity, and acceleration have to be in the same direction. So all of my acceleration arrows here are going to point to the left. And they're all going to be 1 segment long because each arrow is getting longer by 1 segment. So this plus this gives me that. That plus that gives me this. If I kept going, that plus that would give me the next one. And our final example will be decreasing speed in the negative direction. So let's do this one qualitatively as well. We are starting out fast and getting slower. So we'll go 3 segments for velocity, 2 segments, 1 segment, and then let's say it comes to a stop. So it stops after that. My acceleration has to be in the opposite direction of the velocity because it's taking away. So if something is getting less negative, that's because you're adding something positive to it. So negative plus this positive gives me less negative. Negative plus this positive gives me less negative. These two, it would eventually come to a stop. Again, something decreasing in speed, velocity, and acceleration are going to be in opposite directions. So this is how you do motion maps. These are the 4 main cases that you would see. If you've got 2 different types of motion, you would just have, in the same problem, you would have 2 rows. So you'd have velocity, acceleration, say it then turns around and goes the other way. You would do your velocity and your acceleration. So you can have a motion map with multiple rows for velocity and acceleration. Just make sure you label which set of arrows is which.